Okay, so today what we are working on is taking roots, which remember are the same thing kind of as x-intercepts or zeros or solutions to quadratic functions, and we're going to actually be building the equation of a quadratic function from those roots, okay, or x-intercepts, however you want to think about them, okay? So to be able to do that, if you are given the roots or the solutions or the x-intercepts of the quadratic, and you are being asked to write the quadratic equation or the quadratic function, you are actually going to be doing what's called kind of reverse factoring. So think about factoring. When you factor an expression, what you're doing is you're taking it and you're breaking it down into its factors. And so when you solved quadratic equations, one way to do it would be to factor it, and then remember you take each of its factors and you set it equal to 0 and then solve for x. Well, what we're doing today is we're kind of undoing that. So we are kind of reversing that process. So to do that, you're going to now kind of start with x equal to whatever the x-intercept is, and then you kind of undo what was done. So like where you solved, you're going to actually kind of undo that solving part, and then you'll essentially have your quadratic equation, okay? So what we're doing is starting kind of that process of talking about how to actually write the quadratic equation from the roots, okay? So we're going to just do several examples so you can see how it works, and then we'll see how you feel, okay? So in this first problem, it says the solutions, and it's talking about a quadratic equation, the solutions of that quadratic equation ended up being -4 and 3, okay? So that means if you think about solutions, it's kind of the same thing as your x-intercepts. That if you think about the graph, it means it crosses the x-axis at -4 and 3, okay? And what they want you to do is they want you to actually write the quadratic equation from that. So to do that, you are going to kind of essentially start with where you would end the factoring problem and then work backwards, okay? So the first thing you do, so we're going to write some steps over to the side right here. The first thing that you're going to do is you're going to set x equal to each one of those solutions. And if you think about it, when you solve by factoring, that's kind of what you end up with, is you end up with x equals each one of those x-intercepts or those solutions. And so you set x equal to, I left a blank there so you can plug your number in, to each of those solutions. And then after that, you are going to get that equal to 0 now. Because remember, you're undoing it. So get, my marker's going out. Get it equal to 0. And that's actually the part that kind of reverses what was done. Okay, so let me show you what I mean. So the first thing, we know that one of the x-intercepts is -4, so you're going to set x equal to -4. And then the other x-intercept or solution was 3. So you're going to set x equal to 3. Okay, and my marker's going out, so let me switch out real quick. So then from there, you have to get these equal to 0. So you have to actually make it to where this isn't a -4, it's a 0. So how do you do that? Well, think about how do you move something away from that side of the equation? Well, you do the opposite. So to move this -4, I'm going to actually do the opposite of that, which would be to add 4. And so what you do to one side, you have to do to the other. And so notice -4 plus 4 is 0, so that goes away, and then my equals comes down, and now these won't combine, so you just write it out. So you end up with x plus 4. Notice it's equal to 0. Okay, so now you do the same thing here. So to get this equal to 0, I have to move that 3. Well, it's a +3, so to move it, I have to subtract 3. And so 3 minus 3 is 0. And my equals comes down, and then that won't combine, so you just write it out. So that is my other factor. So what you have actually done here is you went from knowing the solutions, and now these are your factors, okay? So from here, you can pretty much set up your equation, okay? So from here, and I'll have to put it in this little section, so let me erase. Once you get it equal to 0, you have your factors, and now you put it in your equation. So remember, factored form is where you have a number up front, and then you have x plus or minus some number, and then x plus or minus another number. So like these are kind of like your numbers. So now the a, we're not going to concentrate too much on today, okay? So that'll come later. But we're going to set it in this form. So to put it in factored form, it's y equals, you take this, the x plus 4, what you got as one of your factors, and you put it in parentheses. And then you take the other factor and you put that in parentheses. That is a quadratic equation that represents this function, okay? So this would, if you actually solve this, you'll notice that it has an x-intercept of -4 and 3. So kind of think about the opposite of what we did yesterday, okay? So that's the factored form of it. Now, if they ask you to put it in standard form, then you have to take that and multiply it out. So if they ask you to put it in standard form, then all you do is just multiply it out. So I'll show you how to do that. So again, this is the factored form. So if they want you to leave it in that form, you're pretty much already done. But if they want you to put it in standard form, then just like what we did the other day, you have to double distribute. So you're going to take the x and multiply it times everything over here. So it'd be x times x, which is x squared. And then x times the -3, which is -3x. Then you're done with the x. Now you take the 4. So it'd be 4 times x, positive 4x. And then 4 times -3, that'd be -12. And then from there, you got to combine like terms. These are our like terms, so we got to combine them. So it'd be y equals, my x squared just comes down. Then I have -3x plus 4x, so that'd be a 1x. So I just write it as an x, and then minus 12. So this would be the standard form of my equation, okay? So that's the factored form, that's the standard form, all right? So there's your quadratic equation, okay? So there's a part B to this problem, so let's look at part B. This one, you actually have to find the solutions and you're given the equations, okay? And then they want you to compare the graphs and the equations of these two that we would have done. So we're going to compare this with that, all right? So to find the solutions when you're given the equations, that's what we've done kind of the other day, where the only way that you know how to solve it right now is by factoring. So what we're going to do is we're going to take that and factor it. So to factor it, you always look to see if it has a GCF, and it does. And so I'm going to go ahead and factor out my GCF. So they all have a 3 that will evenly go into it. So my GCF would be a 3, and then they don't all have a variable, so I don't have to worry about that. So when you factor out the GCF, you write it outside of parentheses, and then you go in and you divide each one of those terms by that. So 3x squared over 3 is just x squared, because your 3 over 3 is 1. This one, kind of the same thing. 3 over 3 is 1, and so that x just comes down. Then divide -36 by 3. So -36 divided by 3, that would be -12, okay? So from here, we look at the part that's in the parentheses, and we look to see if that factors. That 3 is just going to come down. So this is a trinomial, so we've already done the GCF. So a trinomial, we put 2 parentheses, and then remember that equals 0 just comes down. We ask ourselves, what times what gives me the first term? So notice this is one of the basic trial and error problems. So x times x is what gives me x squared. So that just comes down. We put an x and an x. Then to figure out the signs, you look at that last sign, If it's negative, that automatically means that these signs are going to be different. So that you're going to put a plus in one and a minus in the other. Then you list out what multiplies to give you that last term. So what multiplies to give me the 12? Well, I've got 12 and 1. I've got 6 and 2. I've got 3 and 4. Okay? And so out of all of those, you're going to look to see which of those combine to give you that middle term. And they have to combine with those signs. So which of those are going to combine to give me a positive 1 out of it? Well, if you think through it, the 3 and the 4 can combine if they have different signs to give you a positive 1. So think about which one goes where. Well, to end up with a positive 1, the 4 would have to be positive, and then the 3 would be negative, because positive 4 minus 3 would give me 1, okay? So now we factored it. So now to actually solve, that's where you take each of its factors and set it equal to 0. That one doesn't have an x with it, so we kind of just ignore it. So the x plus 4, you take down and equal to 0. Then you take the x minus 3 and equal it to 0, and then you solve. So this one I'd have to subtract my 4. So x would equal negative 4 when I subtract. And then here, x would equal, well, I have to add 3 to both sides, so x would equal 3, okay? So what are the solutions to that problem? Well, the solutions would be negative 4 and 3, okay? So now it wants us to actually compare kind of this problem with that one to see, I guess, if we notice something. So the first thing that I actually noticed is notice what the solutions are to this one compared to the solutions that we actually had in the beginning one. They're the same, okay? So now let's compare the equations. So, and actually about the solutions, remember solutions are the same thing as like x-intercepts. So notice they would cross the graph, kind of comparing the graph, they would cross the graph, the x-axis at the same places. So they both cross the x-axis at negative 4 and 3, okay? So now let's compare the equations. Well, if I look at this one, and I'm going to erase this because that was just kind of my work for the GCF. If I compare this one with the equation I got here, notice they're not exactly the same equation. And the reason for that is because this one had a common factor. So notice once we factored out that common factor, that part inside of it ended up being the same, okay? So just kind of comparing the equations, they're kind of similar, but this one, just all of these had a common factor, okay? And so, well, is there anything else different? Well, if you kind of think about, this is in standard form and that's the standard form there, the y-intercepts are actually going to be different. And so just some comparisons, all right? So with this, I wanted you to realize that some equations could actually end up with the same x-intercepts, but they may not be exactly the same equation, which would be is interesting to realize, okay? So let's do another one where we're practicing writing the equation, okay? So that you can see another example of that. So number 2, it says that this equation, or this quadratic, is going to have a solution of 5, and then it says the multiplicity of 2. So when it says something like this, what that actually means is this solution actually happens kind of twice. So it has 2 x-intercepts, but they're the same thing, okay? So how do we write that? That means that when you solved this one, kind of like what we did here, when we solved it, you ended up getting x equals 5 and x equals 5, okay? 2 times that you had an x-intercept of 5, okay? So multiplicity of 2 means that you have 2 factors that ended up being that solution, okay? So how do you do that? Well, how do you write the equation? You follow those same steps we did for this one up here. You start by setting x equals to each of those numbers, so I've already done that. So I'll just copy it over here. So you take x equals 5, and then we had another one where x equals 5, and then you undo it. So to undo it, remember, you had to get it equal to 0. So how do I get this one equal to 0? Well, I got to get the 5 to the other side. So that means I have to subtract 5, and then you have to do it to both sides. So 5 minus 5 is 0, so you end up with 0, which is what you wanted. These won't combine, so they just come down. And then same thing here, subtract 5, so you'll notice it's the same thing. These go away, my 0 comes down, and then those won't combine, so I end up with x minus 5, okay? So from there, remember, these are actually your factors in that equation. So you can go ahead and put it in factored form. So to put it in factored form, you take each of those factors and put them in parentheses. So it'd be x minus 5, okay, just like that. So those are the factors. You just take each of those, put it in parentheses. And so that would be the factored form. So if they just want you to put it in factored form, you're done. It's the factored form. Ooh, it's hard to write at this angle. But if they wanted you to actually put it in standard form, remember that's where you have to kind of multiply it out. So if we were to put it in standard form, we would multiply that out. So let's do that to practice that. So standard form. We take everything and multiply it. So x times x, we got x squared. X times negative 5, negative 5x. And now we're done with the x, so now we move to the negative 5. So negative 5 times x, negative 5x. And then negative 5 times negative 5. A negative times a negative is a positive. And then 5 times 5 is 25. Okay? Then, combine like terms. My x squared just comes down. Negative 5x minus 5x is negative 10x. And then my plus 25 comes down. So, there is my standard form. Okay, so now we're going to talk about these problems, because these are a little different, so they might throw you off. Okay, so same question. We're writing the quadratic equation if these are the roots. Okay, so you start them out the same way. This is where they would cross the x-axis, or if like you were solving an equation, this is the things that you would get, or these would be the answers that you would get, and you'd have x equals these numbers. Okay, so the first thing you do is you kind of write down where you would have ended. So you write down x equals each one of those. So I'm going to write down x equals that one, and then x equals that one. And then from there, you have to undo where you have solved it. So before, remember, our goal was to get it equal to 0, and that's still our goal. But notice you have a fraction. So when you have a fraction, you actually kind of want to split up your fraction. So how do you do that? Well, notice you start with the bottom number, and you get the bottom number all first. So like you're dividing by 3 here. So think about what's the opposite of dividing by 3. Well, that would be to multiply by 3. So you're going to multiply by 3, and then again, what you do to one side, you got to do to the other. So you do it to both sides, and notice 3 over 3 is 1, so those kind of go away. And then you have 3x on this side equals, and then you're just left with a 2. So now from here, notice it's still not equal to 0, so you got to get it equal to 0. So it's a positive 2. So to do that, you subtract 2. And then 2 minus 2 is 0, so those go away. And now it's equal to 0, which is what you want. And now these won't combine, so you just write it out. So there's that, okay? So that's, remember, one of the factors of that quadratic equation. Okay, so now we do the same kind of thing here. You're dividing by 4, so to get the 4 off, you multiply by 4, and then you got to do it to both sides. And then 4 over 4 is 1, so those kind of go away, and you're left with 3 on this side. And then your 4x comes down, okay? Got to get it equal to 0, so to get it equal to 0, it's like a positive 3, so you're going to subtract 3. 3 minus 3 is 0, and then your 4x minus 3, those won't combine, so you just bring it down, so that ends up equaling 0. That's your other factor. Okay, so now once you get this part and it's equal to 0, remember these are your factors. So now you can go ahead and put it in factored form. So to do that, you take each of those and put it in parentheses. So the 3x minus 2 would go in parentheses, and then that 4x minus 3 would go, and it's on parentheses. That is the quadratic equation that would have those as its roots or as its x-intercepts. So this would actually be where it crosses the x-axis, and this is the equation for that, okay? And then if you needed to put it in standard form, remember you multiply it out, okay? So if I multiplied that out, just put it to the side here. 3x times 4x is 12x squared. 3x times negative 3 is negative 9x. So we're done with the 3x. Now we move to the negative 2. Negative 2 times 4x is negative 8x. And then negative 2 times negative 3 is positive 6. Then we combine like terms. So my standard form would be 12x squared. And then when I combine these, it ends up being negative 17x and then plus 6. So this is my factored form. That's my standard form, okay? So what about number 4? Well, now you have radicals, okay? So when you have two x-intercepts that have a radical, if it's the same thing under the radical, you can actually kind of shortcut this one, okay? So notice you've got a positive square root 3 and a negative square root 3. So when you're doing problems like that, the first step would be you take x equals to each one of those. If you think about how square roots work, when you square root something, remember there's actually two answers that you have. You have a positive and then a negative. So typically we would put plus or minus our answer. So here we're going to actually put those together as one. So like this would be a positive negative square root 3 because that actually represents what you see here, okay? And that way it actually makes the next part a little bit easier. Because think about it, to get rid of a square root, the opposite of square rooting something would actually be squaring it. So what we're going to do to get it equal to 0 is we have to start by squaring that. And what happens is squaring and square rooting are opposites. So it actually gets rid of all of that when you square it. So it does all of that for you, okay? So from here, the square root and the square canceled, and so you're just left with x equals 3. And so that makes it kind of easy. But remember, oh, and I just realized something. Oh no, what you do to one side, you have to do the other. So sorry, I forgot to do that to the other. So you're actually left with an x squared here, okay? So then from there, you have got to get it, the 3 to the other side because you got to get it equal to 0. So you've got to subtract 3 so that you can get it to the other side. So 3 minus 3 is 0. And then you have x squared minus 3 won't combine, so you just write it out. And notice it's equal to 0. Okay, so when you do that, notice this is a factor of it, but you have actually already kind of done the whole problem rather than having to do two different things. You've kind of put them together and it caused 1. So again, anytime you have a radical and it's the same number underneath it and one of them's positive and negative, you can kind of put them together and then you solve it for 0 and you'll have it. So this is it. So that would be your equation. So when you write the equation, it'd be y equals, and then that's all you got. You got x squared minus 3. So there we go. Okay, so let's do one more and then hopefully this will help. So what do you do when you have to write the equation when the x-intercepts are 0 and negative 4? Same story. Start by writing the end of it. So you're going to take x equals each one of them. So it'd be x equals 0 and then x equals negative 4. Then you get each of those equal to 0. Well, notice this one is already done. So this would actually be a factor of your problem. So notice once we got it equal to 0, this was the factor of it that we would put. So we're already done with that one because it's already equal to 0. So now we have to get this one equal to 0. So to get it there, we're subtracting 4. So the opposite would be add 4. So we'd get it to the other side. So we're going to add 4. So then x plus 4, those won't combine. So we just write those out. And then negative 4 plus 4 is 0. So we get 0 on that side. So that's a factor of this equation. That's a factor. Now we can put it in factored form because they're both equal to 0. So you just take that one, and it's only one term, so you don't necessarily have to put it in parentheses. You can, but you don't have to. And then this one has more than one term, so you put it in parentheses, and then there we go. That would be your equation. And then remember, we usually put y equals. So that's the factored form of it. If you needed to put it in standard form, remember, you just multiply it out. So you would take your x and distribute it because you just have an x out there. So x times x is x squared. And then x times 4 would be positive 4x. So that would be your standard form. And notice it doesn't have the plus a number. So if it doesn't have that, that technically means that your y-intercept would be 0, okay? So that's the factored form. That's the standard form. So that is how you write a quadratic equation when you're given the roots or the x-intercepts, okay?